Today I will be discussing the next part of this interest calculation, that is compound interest. In this case, interest will not be same as before we have discussed in simple interest, but interest to be calculated on the changed amount. That is what I am wanting to say, that is interest on the increased or decreased balance of the principal sum. When the interest is added every time, the principal sum will be increased, or if it is decreasing, in the case of depreciation we used to see that, then the interest on the decreased amount. So what we have in this topic, final value to be calculated with the help of some formula. Annually, if I take the calculate, and annually if I calculate, the amount will be principal 1 plus r by 100 whole to the power t. Here t is time in years, p is principal, and what we have discussed, r is rate. They are compound interest, rate in compound interest. The problem is this formula is not just added but is multiplied, and this is annual mode of payment. The interest is or calculated annual calculation. In the chapter compound interest, it may not be annual, it may be half yearly, quarterly, or even monthly or daily. So when we divide the interest payment, that's interest calculation, in half yearly mode, if we calculate half yearly compounded, when the interest is compounded half yearly, then the amount finally will be p 1 plus r by 200, and the time will be double, because every year 6 months, half yearly means 6 months, after 6 months the interest is paid. So in this 1 year 2 times interest will be paid. So in t years it will be 2 times t, whereas the rate of interest will be half. Whereas if it is quarterly, that is 3 months interest, quarterly compounded, then we are having the formula to be amount finally p into 1 plus r by 400 to the power 40. And of course, if it is monthly compounded, that is every month the interest is calculated, then our idea will be to find the final amount to be p into 1 plus r by 1200 to the power 12t. So what we have in this total discussion, that how many times the interest is paid. 2 times means 6 months, half yearly or semi-annually. Then this formula, quarterly means 3 months, 4 times interest paid per year, and 12 times, that is monthly interest, then it will be 12t on the in the power and r by 1200. Now 3 types of problems we can find. Before that, one more point, that compound interest CI is calculated by subtracting P from A. So this calculation, simple interest is PRT by 100 in the case of simple interest you have found, but in compound interest it will be finding the amount with the formula, then subtracting the initial value. P is the initial value. So there are 3 types of problems. One is investment, another is loan, and the other one is depreciation. But another kind of problems we usually find, that is population. The population also increases when we calculate the increase in the population, that is of course compound interest. Depreciation, what I am saying, depreciation is also compounded, and the formula will be scrap value. Scrap value will be original price P 1 minus r by 100, instead of plus it will be minus, because it is depreciating to the power time. So P is the original price, and original cost of the machine or whatever the item is. R is annual depreciation rate, annual rate of depreciation, and T is the life or expected period of the item or the machine, whatever it is. Now, first problem which we can discuss for this topic is rupees 4,000 is invested at 5% CI compound interest for 4 years. Find the amount and the CI, that is compound interest. Here I have not mentioned what type of interest we are getting, that is annually or half yearly or quarterly. So what we will be doing, we have P as principal, and that is 4,000, rate that is 5%, and time is 4 years. So what we will be calculating, amount A is 4,000, that is P into 1 plus R by 100, 5 by 100 to the power 4. Now we can use calculator, or otherwise we have to calculate with the help of normal multiplication rule. In most of the cases we have the scope to use calculator. Then we calculate, this is 1.05, 5 by 100 is 0.05, 4 times, and when we multiply it, ultimately after multiplication comes to 4862, that is 4,862.03. So this is the final amount, and CI will be this amount minus the principal, that is 4862.03 minus 4,000, that is 862.03. So this is a problem which is a simple one. Next question we can discuss is rupees 16,000. Rupees 16,000 is invested for 1.5 years at the rate 10% CI, payable half yearly, that is 6 months. Now find the compound interest. Find the interest when it is compounded half yearly. So what we are having, P is 16,000, R is 10, time is 1.5, but 6 months, so we need 2 times T, which is 3. Actually it is 6 months interest, therefore 1.5 years will give you 3 times interest, 3 times. That is why we are getting this 2T. So finally we are getting the amount as, formula will be A is equal to P into 1 plus R by 200 whole to the power 2T. So it will be 16,000, 1 plus 10 by 200 whole to the power 3. So calculation, this is the calculation, and what we calculate here, 16,000, this 10 by 20, 200, 10 by 200 comes to 1.05 to the power 3, and after multiplication we get 18522. Therefore 18,522, CI will be 18,522 minus 16,000, that is 2,522. Now another problem we can do here, that is find the amount. Find the amount. Find the amount after 6 months. If rupees 4,000 is invested, in this case if it is not invested, it is a loan, then also the same idea will be considered. The 4,000 is taken as a loan with CI, here it is CI, 12% per annum payable quarterly. So the question is, if it is quarterly compounded, then how much amount we will get after 6 months. I missed this 6 months. So find the amount after 6 months. If so this 6 months is very important, because this time period is 6 months. We will not say, we say T by 6 by 12, that means 0.5 year. But question is quarterly compounded, therefore we need 40, that is 2 times, and principal is 4,000. Rate of interest will be is given as 12%. So our formula will be, the amount finally we will get as A is equal to P into 1 plus R by 400 whole to the power 40. And according to this idea, what we have found is 4,000 into 1 plus 12 by 400 to the power 40 means 2. Of course 3 months interest, that means 6 months it will be 2 times, and our result will be 1.03 whole square, and after multiplication twice our result is 4,243.6. So this is the amount after 6 months. In the case of loan, if compound interest is charged, normally we find most of the business transaction loan will be calculated on the basis of compound interest instead of simple interest. We consider P as the principal, but we can say present value of the loan. Present value of the loan means principal, which is the loan amount. So principal is the loan amount, we can say that is present value, and the final amount to be paid, this is the final amount to be repaid, that is A. So repayment amount, finally we write A and P the principal. What we have calculated the same manner we will calculate. So we can have a problem, find the present value of a loan. Find the present value of a loan of rupees loan due in 5 years when rupees 10,000 to be repaid. That means in this question what is and CI, the compound interest, is 9% per annum. Therefore it is 9% interest compounded annually. It is not mentioned annually. Normally when it is not mentioned we consider annual compound interest, and the loan repayment amount is 10,000. We are asking the loan, how much loan was taken, that is the present value of the repayment amount of 10,000. So here amount is 10,000 and repayment amount 10,000 means A. A is 10,000 and the principal value of the loan means the present value of the loan, that is not known to us, and rate of interest is 9% and time period is 5 years. So our formula will be 10,000 is equal to P into 1 plus 9 by 100 to the power 5. That means 10,000 is equal to P into 1.09 to the power 5. Now many ideas are there how to calculate this P. Simple idea is 10,000 divided by 1.09 to the power 5. Now you have many ideas. Mostly we calculate with calculator. 1.09 5 times we multiply and when we multiply 1.059 5 times, then our result will be 5 times multiplication leads to the calculation as 1.5386. So that is 1.5386, and we divide it 10,000 and the result will be into divide ultimately gives the result to be 6499.4 approximately. 6499.3, not 4, approximately 3-4. So the result we are finding is the principal. Now one problem for depreciation we can discuss. Depreciation said find the scrap value. Find the scrap value at the end of 10 years. After 10 years, how much will be the scrap value if the cost, original cost is rupees 10,000 and the rate of depreciation is 10%. So obviously it is also per annum. Therefore what we will find, the scrap value will be, if I write SB as scrap value, if it is not denoted we can think that is scrap value as SB, and that is P into 1 minus R by 100 whole to the power at the time, and the result here 10,000 into 1 minus 10 by 100 to the power 10. So 10 by 100 is 0.1, 1 minus 0.1 is 0.9 to the power 10. So we'll multiply 10 times, 0.19 10 times, and calculation gives you finally 3486.78. So this is the scrap value. Now another point, two more things I will be discussing. First thing, the effective rate of interest. It's a very important point. What is the effective rate? Effective rate of interest, means equivalent annual rate. Equivalent annual rate if compounded more than once in a year. That means half yearly or quarterly or monthly. Then we want to know how much rate will be the 6 months, 3 months, 4 months mode of payment. So we have a formula for finding effective rate. This is effective rate is equal to 1 plus I whole to the power n minus 1, where I is adjusted rate. Adjusted rate means for half yearly I will be R by 200, for quarterly R by 400, and for monthly it will be R by 1200. And n, this n will be number of conversion in a year, means 2 for half yearly, 4 for quarterly, and 12 for monthly. Now we have a we can have a problem. Find the effective rate of 8%. Find the effective rate. Find the effective rate of 8% compounded semi-annually. The semi-annually word means 6 months. Semi-annually. So here what we are having, this rate R is 8, but N is 2 because 6 months, half yearly. So I can have R, I is R by 200, that is 8 by 200 comes to 0.04. So our calculation effective rate will be, according to this formula, effective rate is 1.04, that is 1 plus r by 200 whole to the power 2 minus 1. It comes to 0.0816. If it is expressed in percentage, this means 8.16%. So 8% interest annual is actually half when paid half yearly, then effectively you are getting 8.16%. That means the conversion will be for 2 times a year. Now the last problem I would like to discuss today will be find difference between simple interest and compound interest. That is compound interest and simple interest. Difference between compound interest and simple interest on rupees 2,400 for 3 years at 5% per annum. Now what we can do, find the simple interest, find the compound interest, then we'll subtract, but we can calculate directly. That means the difference we can calculate directly. The CI part will be 2,400 into 1 plus 5 by 100 whole to the power 3 minus 2,400. This is a CI. And SI part, the simple interest part, will be 2,400 into 2,400 SP into R. R is 5%, 3 by 100. So if you watch this expression, we have a very quick idea. If you take 2,400 common, that means this and this, we will get 2,400, then 1.053 times minus 1 minus 15 by 100, which is 0.15. So if I take together, then it is plus with a bracket, that is 1.15. So we will multiply 3 times 1.05. When we multiply 3 times, we get 1.157625 minus 1.15, and this 1.15 is subtracted, that means 0.007625, and the final answer is 18.3. that is 18.3 is 18 rupees 30 paisa, the difference of SI and CI. So that's all for today. That is regarding compound interest. We have discussed mainly basic ideas of compound interest, and we have used different we have seen different problems of loan, investment and depreciation, and finally effective rate and how to calculate the CI and SI difference. Thank you very much for today.